to check out, pick up a barrel
Yeah,
first?
let's get a barrel first.
So let's send us a barrel pickup, Tucker.
All right.
Just here.
So what you're checking now is our first primary obstacle avoidance, no touch. We also have a secondary one which does involve a touch. We can demonstrate that just in a minute. So right now it's getting ready to turn into barrel. It's going to pick up a barrel. We are allowed some misalignment adjustment, but ours tolerates a pretty good misalignment and still picks up a barrel. This is our second gripper we actually designed. The first one turned out to be a bit too heavy. So we redesigned and saved a lot of weight and actually ended up with some, I would call it flimsiness, that helped. It made it a little more tolerant. The other one was really big and tight and rigid. It's actually over here. You can look at it later if you want to. This one actually tolerates a little misalignment because of that.
So when did that design change take place?
A week ago.
We had plant manager's approval for that.
Yeah, yes. So the barrel subsystem was actually within its weight requirement, but after integration, when we got everything together, we found out that we were 80 grams overweight. There weren't any great places for us to save 80 grams, so we found some technical difficulties with the barrel pickup system at that time. Servos were being used in ways that the $1.50 servos just didn't want to be used. So I said, well, let me see what else we can come up with, and that's what we did.
Do we have to pay him?
Yeah, so he's our mascot. You'll find that he just improves the morale of the plant.
It's pro bono work.
Right.
He's a second pair of eyes for the magnetic particle.
Yeah, right. That's what it is. Okay, so let's go to drop off.
Drop off? Did you guys time yours? Is it under the time limit?
Absolutely.
No one has.
Yeah, the time turned out to be not an issue at all. Weight was a bigger challenge than time, and the whole other slew of requirements.
Does it meet the weight requirement?
Yes, so we've actually got a scale set up over here. We're going to demonstrate that for you. We've got a list of requirements. If we haven't ticked them by the time we get there, I'll just go through them one at a time and just demonstrate those things for you.
Excellent.
I'm not going to go through the whole list, but I've just got a few highlighted that we want
It's
to
gonna send
demonstrate.
WMS the code to the break.
Right, so you can see our color sensor right here has identified the color of the barrel.
Look at that.
He's showing us the brick here, and that was a white barrel, so it should show color 2.
Did it just push them all to the end?
Yeah, so that was one of the requirements actually. There's a light sensor, a pretend light sensor out here, and the requirement was that we had to close that gap to less than 1/8 inch in order for your computer to know that there was a barrel there. All right, so next let's send it to temp and inspect, because I'd like to demonstrate us running over a dowel rod. Although we have tested it on a variety of locations,
Which way is it going?
the longer it'll go all the ways around this direction.
You're gonna have to hold it because it'll just push it.
I prefer you didn't test it on a short straightaway, but sure, let's go ahead.
Fair is fair.
No, we're good. Just because they chose that one.
Just because the other two groups did.
Well, if it goes over it, it's saying something, right?
Nailed it.
So we're now going to take a temperature. I said we're now going to take a
Yeah.
Sorry.
I heard not too.
I did or not.
As the other groups noted, we did find out when we were pretty far along in the design that we may or may not be inserting the thermocouple or the thermocouple in and far enough to get an accurate temperature. But we've had pretty good results, so we wanted to demonstrate that anyway. You can see that right now it's setting at 104 degrees. So we're hoping that WMS is going to receive a temperature really close to that. While you're waiting, notice our warning label on the back. You may be entertained by reading a copy of that warning label, just to kill the 90 seconds.
Push it back for more accurate. Sure.
So just while you're reading that too, I'm going to go through a few of these. No human interaction. I think we've demonstrated that so far. We're going to continue to demonstrate that. We have a tape measure where you can just believe me that it's less than 9 inches wide. So here is a 9-inch tape, and we are within the 9-inch requirement. We're actually somewhere around 7.5 inches, I think. We also need to demonstrate the ability to run over a break less than 1 inch. So I'm just gonna grab one of these guys here. White piece of paper. So on our way to the next cell, we're gonna ignore any break in the line that's 1 inch or less. Do you want to take that down? Should I tape it down?
Yeah, just in case.
I got you. You guys passing the warning label around? That's your
It's very- it's very
that's your
good.
entertainment for these 90 seconds that you wait.
Fantastic.
Another thing.
Who wrote this?
I just got something right here.
Oh, it's on the
Big
device.
print
It's hard to read
Make sure
it on the
that was the
device.
most important thing on there.
Another thing that requirement that we've demonstrated is a clearly visible safety stop button. I don't think you'll have any trouble finding our safety stop button. To scale, you might have to
I'm
be pretty.
colorblind, so you know.
You might have to be pretty tall to reach that if you're the size of the Lego guy. But we were recommended to put it on top. So run over an object 3/16 at a 45-degree angle. We demonstrated that. He's showing temperature. Tell us what you get.
So 90 degrees,
90 degrees,
92.
92 degrees. So we had testing that was a little better than that, but maybe we just got lucky that day.
Yeah, well, we pulled it off.
Right. So we've demonstrated the two means of detecting objects, both a no touch and a touch. Tucker, if you would, let's send us over to MagInspect, please. We're going to check for magnetic particles. So on its way there, I'm going to demonstrate a few things. I'm going to demonstrate its ability to continue driving even though there's a 1-inch break in the line. Go ahead. Demonstrate the safety stop button. Also, you'll notice at this time, there's a timer running here. One of our requirements was to monitor the available time, and that timer is running. So as long as we clear that code within that timer, it's going to continue on about its way. If we don't, it's going to stop, it's going to notify WMS, and we can certainly wait 4 minutes and show you guys that, but it's going to notify WMS that there's an issue and normal or manual operations are going to resume. So,
But I do want to hear get it going again.
sure, we'll demonstrate the beep.
Yep.
So it's going to continue. And let it run over that. No issues there. I don't let it go this time.
When do you hear the beep?
He counted to 4 and then he let it go and
And
then
there's
started
our
going again.
beep. Audible warning. Alrighty. We demonstrated the barrel and the pushing the last barrel. Hey, it worked. That's why that's there. That's our 1.5. Let's try that again. So one of the requirements that I wanted to point out for this was we had to be able to scan the table within this very light line you can hardly see, plus or minus a 1/2 inch. What you'll notice is that we're going to more than cover that table. We've actually checked for magnetic particles anywhere on the table, and we're able to pick them up, even underneath the table. That was kind of our plan. You were going to get
I'm sorry.
you were going to get a magnetic particle detected, even though there wasn't
We
one
would've got
there.
us all excited that
Right,
was
yeah,
on.
it's all good. So there's
So what
our.
number are we looking for?
You should receive a 4.
Right.
The WMS should receive a 4
Let
for
our QA inspector see a 4.
Your drive now?
Yes, so we
yeah.
took your
Yeah, we're
advice
gonna sand
about the drive
Yeah.
wheel, the tire,
Yeah.
and actually the next day, this was being 3D printed. So we have, this is now operated via drive gear system
Yeah.
instead of the tire that we had on there. And that was one of my lessons learned. I'd say I was pretty attached to that design, but the more I got to looking at it, we were having to do all these things to make it work, and it was like, this is just common sense. And I needed somebody else to tell me that was common sense, as simple as that sounds. So definitely. So I think we've run around. The only other requirement I really wanted to point out was our weight requirement. We will certainly do any other testing you'd like
Do
us
this
to do.
one again without the magnet.
Okay, so just send it back to MagInspect. We can also show you a different colored barrel if you'd like.
Any other requirements we're missing? You said you'd weigh it for us.
We're gonna weigh it. That's the only other one I really had on here that I wanted to point out, but we haven't yet. I've certainly got the whole list of requirements here if you want to browse through them. But all but one time we've demonstrated no human interaction.
Which will clear up this patch.
Good deal. We demonstrated going over 3/16. We showed a primary and secondary optical detection.
And we're looking for what number?
So
Look for a 3.
a 3. If it's clean powder with no magnets in it.
And there are none taped underneath.
Right. Not this time.
That wasn't a fake refit.
Whose idea was it to put the skids on?
That was mine.
That was- he's our
We were
drive
having
guy.
some issues with the drive going over the, well, 3/16 dowel, so.
Like everybody else was telling you earlier, we've been using an 1/8" dowel rod. And so didn't think it was an issue. And then all of a sudden yesterday, I just happened to pick up a pair of calipers. I was like, oh crap, this is not 3/16 of an inch. So that was some great last minute thinking on Nick's part there. Yeah, all right. So we've got a
12.
scale set up over here. 12? Yeah. So we've got a scale set up over